everyone. Good morning. I've traveled a long way to come here today. I'm from Seattle, Washington, so it was a very long journey to get here. And before I get started, I want to just thank our partners, Rated Power, for inviting us to this conference. We're sponsors of this event, and like mentioned, we do have a dinner tonight. So look forward to meeting all of you and just soaking it all in. It's been a very great first impression so far. So just to get started, my name is Han Bui. I am the lead product manager at Clean Power Research, and I lead the SolarAnywhere product line. We provide bankable irradiance and weather data sets for solar project development and in operations and maintenance. So the topic today is data uncertainty in solar development. So irradiance uncertainty is well acknowledged in solar prospecting. If you're a large-scale solar developer or you're in design or kind of early stage projects, terms like TMY, time series, interannual variability, P50 estimates on solar installation annually are probably familiar terms that you've heard about before. And they're central to understanding what the return will be on your solar project. SolarAnywhere provides this bankable irradiance data, and we do this globally. We have done this for many years. Clean Power Research has been a company for 25 years, and we have deep experience both with utilities and in solar developers and providing this data in this space. And the factors that affect this irradiance bankability are validated accuracy, consistent results, having the right spatial and temporal resolution so that you get precision at your site, and that we have a long history of resource. So speaking for SolarAnywhere, we validate our sites in a network of ground stations all over the world. Our model is consistent over satellite regions and geographic regions. Our resolutions are down to 1 kilometer, we have sub-hourly, and we have over 25 years of historical data globally. So a lot of this isn't new. It's usually the first step in prospecting as you look at solar yield at a site. But what I want to focus on in today's presentation is going beyond irradiance of just how sunny it is at a location, and to give more insight into what other data sets should be used in project assessment. So these are things like snow losses, soiling losses, albedo, wind speed. You can read the list there. Because these are important too. It's not just solar resource. It's a lot of other factors that you should be considering in your project holistically to understand the risk long term. So in the rest of this presentation, I'll run through a couple examples of these data sets and how they pertain to solar development and the strengths and weaknesses of each, the research we're doing to understand what new data sets are on the horizon and to respond to the different needs of the solar industry. So I want to start with soiling. So unmitigated soiling can contribute 1 to 4% uncertainty, that's about 1 sigma, in P50 energy estimates. This is something that is, very hard to model, notably because of these models, these soiling models are more empirical in nature. So the science is not exact. There is no first principle that describes all soiling, and it's an active area of research for many institutions to understand the different types of soiling and how to mitigate it at scale. What's done today is usually design firms or O&M, they'll go through 2 approaches. One approach is they'll use their experience in operations to estimate soiling costs in a region where they've, have experience in. And the other is you'll deploy a soiling kit for a short amount of time, maybe a year. There are problems with these approaches. So solar is being developed in new regions, so then you don't have that operational experience anymore. And then if you do an on-site measurement, it's only for a couple of months, maybe a couple of years at maximum, and it's hard to extrapolate something like soiling that has very high interannual variability to the lifetime of the project. So that's not ideal either. Our solution is to support multiple soiling models in conjunction with your current risk analysis. So you can look at that soiling trend in a 20-year time frame, for instance. And we're combining these with observed weather data sets and things like precipitation, wind, particulate matter at the site-specific location that can complement the analysis you're doing. So this is a longer-term view that is not perfect, but gives you a better picture of your soiling impact that can happen through the lifetime of your project. Analogous to soiling losses is snow losses. Maybe not a huge problem in Madrid, but solar is expanding all over the world. We see projects in Canada, in the northern United States, in the Nordics. So as solar reaches these higher latitudes, it comes the need to understand what are the snow losses in these regions. We don't have a lot of operating experience there, but we do have these models, our empirical models that are being developed over time. Things like the Enroll-Marion model, the Townsend model that can be applied in the same manner as before to the long history, the 20-year history of historical data we have. Usually when looking at a topic like just solar resource, interannual variability is maybe 3 to 5%. In this chart on the right, you can see how much it can change year to year. 1 year, the maximum snow loss may be 85% because it's a very very snowy year, your panels are covered, and then the very next year it may be low as 12%, and that was in data we found in our survey, in one of our studies. So the frequency and severity of these snow events are not ratable, and it causes a lot of uncertainty to how much power you're going to get from the asset year to year, and that's something that should be considered. There's also design implications and maintenance costs to operating in these high latitudes. So using these data sets, weather data sets, modeling data sets, to complement your project up front in design, it's going to help you long-term in your project. In this image here, I'm giving an example of our data at scale. So on the top, we have soiling estimates across the Mediterranean using our data sets, and on the bottom, we have an estimate of maximum soiling loss over the continuous United States. So in terms of prospecting for solar development, I think the landscape has changed a bit. We're no longer looking at a cluster of sites, but our most advanced users are using our API to automate a lot of this prospecting, incorporating machine learning, looking at this data at scale. And SolarAnywhere is behind a lot of that analysis that's happening. You can do a hyperparameter search on all the PV design characteristics to optimize over a very large region where you should build and why and what you should build. So, I think enterprise scale data is the future, and it has a part to play in this sort of risk analysis, and SolarAnywhere is responding to that industry need. So I'll go through a couple more examples here. This is something exciting that our research team figured out in the last year, is we figured out a way to get high resolution horizon profiles anywhere in the world at a 30-meter granularity. So usually when you're looking at shading losses, you have to deploy instrumentation at site and do a survey. That can be costly and take time. But you still need to consider the shading impact in the design of your project. So one approach to that is to use these elevation data sets, get that horizon profile, and model that loss up front. And this image on the right gives you a very exaggerated, cherry picked example of an island in Hawaii, Oahu. It's very nice if you've ever visited. But you can see the topographical obstructions, as the sun moves across the horizon. Long term, if you're not careful about this, you can shave 1 or 2% off of your power. So it's something to consider in optimizing your design. Another trend we've found is in the last couple of years, bifacial panels have become more popular. They've become a lot cheaper. And especially for technologies like bifacial, albedo becomes more important. How accurate is that? Are you getting the granularity and update of your albedo over time to properly model it? So in one study, we found that using an appropriate albedo value in power modeling reduced our error by 20%. And this is especially true in snowy locations where you have a lot of reflection, or in arid locations where the ground is light and you will have reflection from the surface as well. So in conclusion, you should consider a lot of data sets to characterize the risk of your large-scale solar development. There's a lot more than just solar irradiance out there, and I've covered just a few of those topics today. So the soiling losses, the snow losses, albedo, the horizon profiles. More recently, we've had a lot of interest in wind gust data for storage, for stowage of the panels, extreme weather events like wildfire smoke losses, and temperature deviations, you name it. So the demand for these data sets is changing. Risk is changing. Solar is maturing as an industry. And I just wanted to highlight that this is a dynamic space. And at Clean Power Research, we're always looking for the next data set, the next model to incorporate and serve our clients. So that's all I have today. Thank you.